What's up guys, Dennis here, and today we're going to take a look at my CNC machine. I hesitate to call it a mill or a router. Let's call it a machine, right? So this is something that I haven't shown on the channel before, that I just realized, but it's something that I actually built before this channel even existed. So I'm working on it again, trying to get it up and running, and so this is going to be kind of like a current status. I don't know if we're going to actually get this fully operational in this video, but just kind of wanted to show it off. So enough of my face. Right, so here it is. This is something that I built, oh gosh, 10 years ago? So I used to have access to a hackerspace that had a machine shop, and I knew at some point I wouldn't have access to that hackerspace, so I decided to build a CNC machine while I was there. This is a weird machine because I'm not going to suggest you try and build this thing. And I can't give you a parts list because most of this stuff is actually salvaged parts and stuff, or completely scratch built. And the scratch built stuff took way too much time, but it was fun to do. So yeah, totally impractical, and I think really cool. So this entire thing is built on a steel frame that's a 2-inch square tube that's 1/4 inch thick. This stuff is heavy. I actually milled the ends of the steel bar to kind of mate. So I thought that was pretty cool. This is a milled slot, so I actually welded this thing up and then put it on a Bridgeport and milled 2 flats across the front and back. So those are completely coplanar and flat and level. So these extruded aluminum bars I actually milled as well. So these have been milled parallel, flat on the top and the bottom, just to eliminate any possible imperfections from the extrusion process, which for a machine like this, totally overkill. The rails, so this uses linear bearing rails, and these I got from eBay, and I sourced them over the period of like maybe a whole year, just looking for deals for, because these are expensive, especially like 10 or so years ago when I built this, I didn't have any money, so so these were eBay scores. Oh, the Acme rod has looked like it's had better days. So there's 2 Acme rods here. There's another mechanism, but I'll get to that. Yeah, these couplers I bought. There's some bearings in here that I bought, thrust bearings basically. This whole shaft actually floats to accommodate any like misalignments with the motor mounts and the way the motor is. I didn't want this to bind. Something like this, that's you build it very precise, and if you constrain it too much, you know, this is a long stretch, this x-axis here. If you don't have everything completely lined precisely, so it can bind. So what I did was basically engineer in some places where it's not constrained. Let's see. There is underneath, well, there, of course, there's a nut. I spent a long time trying to engineer my own anti-backlash nut. And in the end, I ended up, I thought I had a clever design, and it ended up binding on me and everything. And this is tricky. This is a really tricky thing to get right. In the end, I ended up buying the nuts. I believe they're made out of Delrin or something similar. I'm not going to take this thing apart. No way. Just to show you. But they're in there. I did buy those. Those weren't too expensive from what I remember. The end of these Acme rods are turned down and then threaded. I think it's like a 3/8 by 16 or something thread. And then I never got around to getting nylock screws or nuts. So I ended up putting a set screw to hold that in place. But basically I tension this whole thing, and then the set screw keeps that bolt from like walking off. But a nylock probably would have been just as good and maybe a little bit easier. The stepper motors, these came from some old dot matrix printers, like green bar type printers, and they still work. Z-axis was an eBay find. So this entire thing is just bolted on to the head. Well, it is the head basically. You know, I had to make some of these brackets and stuff, these standoffs. I turned on the lathe, purchased the coupler. Again, there's some bearings under here, thrust bearings. The spindle is completely scratch built. The only part of this that obviously, the belt, the pulleys, I purchased from, I don't know if they're still around, SPD, SPI or SI, or like some like site that only sells a bunch of like gears and stuff, and their site's like a bunch of letters and stuff. And then this was like something from China. This is an ER type collet. I forget if it's ER16? ER16 collet holder with a straight shaft. I think it was a 10 millimeter, and then bearings on either side. I bought a bunch of bearings, I bought a bunch of shafts, and I found a combination that were super tight so that there was no, almost a freeze fit. I put this in the freezer, warmed up the bearings, pushed them together. In this block is a custom machined, totally manually machined block of aluminum. When you're pressing bearings into aluminum, it's a lot more forgiving. You can swage them in. You can just kind of tap, around the aluminum, press it in to give a tight hold on that bearing. So the only part that was really tricky was getting a tight fit between this shaft and the ID of the bearings. This motor, no idea where it came from. This was like something I found in a dumpster, and it's just been kicking around waiting for a project. It's a 30 volt. So this is a 30 volt motor. So it can take at maximum 30 volts DC. And with a spindle like this, if you're driving it with just a straight up permanent magnet motor, straight up DC motor, it's not a servo motor, you have to compensate for the load. So this is something that I'm super proud of. This might be the best thing I've ever built. This is a spindle controller for this machine. Well, I can open it up because I'm in the process of mounting this, so I took the front cover off. So it's basically Arduino, but it's it's just the chip on a PCB that I custom made myself. And so it is the Atmega chip with the Arduino bootloader on it, but it's not, it's obviously not an Arduino board. There's no little mini Arduino hiding under here. This is, let's see. I don't want to take this apart. I really don't want to because it works right now. I'll show you more about this after I get it like actually hooked up to the machine. Okay, so where am I at with this? This was in this box basically since I moved here. And I just never cleaned it off, got it set up. And one of the reasons was, although it worked, and it worked pretty well, it had a bit of a limitation with the stepper drivers because they were homemade. So let me show you what they look like. All right, so back when I was originally building this, the only really stepper drivers within my close to my price range were like the Gecko G540s. Stepper drivers were still really expensive. I mean, that was still several $100s that I didn't have, so I had to make my own. So that's exactly what I did. These, I forget the chip these are based on. They can do half stepping, but they can't do micro stepping. These can drive stepper motors, and it can't go fraction of a step. It can go like 1/2 of a step. So you end up with a lot of noise and a lot of like, it sounds like an old printer. Yeah, so not ideal. These got really cheap. These are now like 25 bucks each on Amazon. So it was time to finally upgrade, and I could get rid of this whole big. I can get rid of this whole big box, and here are the stepper drivers that I bought. So my idea is, this is the old computer that's going to run the whole thing. So I put Linux on there, and I've got Linux CNC, which is a controller program that can control the stepper drivers. Got another piece that I need to put on here. This was in my original stepper driver box. I debated whether I actually needed it. So this is basically an interface between a parallel port and then a bunch of opto isolators to send the signals out to the motors. I was really tempted just to wire the parallel port like directly to the inputs of these, because if you look closely, these are already optically isolated. So the only other piece though is that I wouldn't have isolation, I wouldn't have a voltage to go to the limit switches, and then so this just makes it a lot more handy. So I am going to include this. So I'm going to mount it here. This whole thing I mounted on a piece of aluminum that was from a LCD display that was broken. It was an old monitor. Took it completely apart, and there's always some nice things in monitors like this, and I like keeping these aluminum panels really handy. So I'm mounting this all on here. Yeah, it's really close to the motherboard and all the stuff going on in here. So I don't know if there's going to be interference that's going to crash the computer, or I don't know, but I'm going to try it. I've got the power supply. This is 36 volt switch mode power supply mounted in here. I'm going to have some DB9 connectors coming out the front. These are going to be the connectors for the motors, just like the Gecko G540 controller has. Same pinout, actually. And I've got those connectors on my coming out of the CNC machine. The thought was originally I was going to someday buy a G540, but you know, there's better things on the market now. Okay, so I got to get these wired up. This mounted in here. I'm making a bracket. This is this is a piece of aluminum rail that came from our old shower that we remodeled years ago, and I just held on to it because I thought, oh, you know, it's sturdy aluminum rail. I can use it for something. And I've been making brackets and stuff out of this, and it's just perfect. So I cut that up. I need to get that mounted to the here, and then to the spindle controller to get that mounted, kind of the control right here. So I got to get this, this all finished. And I'm working on this kind of piece by piece, literally like 5 minutes at a time. So it's kind of really hard to film this kind of video because I'm literally just running down here getting one thing done. I'm just gonna go down and switch the laundry. And then, you know, it's like, honey, where did you go? So, you know, that kind of thing. Okay, so we've made some progress. We've got the machine wired up and mostly operational. This took a long time. The wiring was literally just hours and hours, and it was probably the longest part of putting this thing back together. It's so tedious. You can see at this point I actually already had the power wires connected from the steppers to the stepper motor connectors. These are the heavier gauge, the black and red wires that deliver the current to the motors. But this part here, just measuring some RJ11 telephone wire. So this is a solid wire, that's a twisted pair. And the twisted pair is not really necessary, but it does kind of keep the wires together, a little bit easier to route. And because it's not stranded, but it's a solid wire, it stays in place a little bit better. Really, this is just whatever I had on hand, though. It would have been nice if I had some 4-conductor cable, but... And then this stuff is just some cable that I had that I needed a little bit of thicker wire for providing power from the switch mode power supply to the stepper drivers. So I'm almost finished at this point. Almost. Almost. Oh, right. And now all the control lines for, like, this is the e-stop and the home and limit switches, which I then had to wire up to the CNC machine itself. All right, so I've got the computer all put together. We got our X, Y, and Z axis hooked up. You can see where those things come out of the front of it. So if I wanted to, I could disconnect these, and this flap actually goes up. It would cover those ports. So yeah, on the outside, if it wasn't for this E switch right here, it would look totally like a normal computer. I made a little shelf for this to sit on the side. This E switch is actually the power to the switch mode power supply, the 36 volt power supply. Just in case I don't want to turn that power supply on for some reason. If I'm making updates to the computer or something, I don't need the machine to be powered up, so that just allows me to turn that off. And if there's an emergency, I can slap that switch, turn it off. I got a power strip installed up here to make everything nice and neat. I've got the spindle controllers mounted, and it works. So the way this works is press to change the RPMs, and changes by 100. So it goes up to 10,000 RPM at the spindle, not the motor, but yeah. So set it with this, and then on off to actually turn the motor on or off. Don't mind the bottle of Everclear back there. That's a different project. But yeah, so you can see how this works by, if I just put my finger on here to give it a bit of a load, you can see it's calculating the output percentage. So right now it's putting out like a basically 50% duty cycle to get 5,000 RPMs, and this is the actual measured spindle speed. Again, here's what we have it for a set point. So pretty close. It's pretty good. And then we can keep an eye on the load. If this goes too high, this thing will trip. I'm surprised that didn't trip. If you turn down the RPMs, it gets quieter, but also yeah, there you go. You get less torque out of lower RPMs. So I'm going to I got to reset it. Something's not liking that. Yeah, it doesn't like our low RPMs. Okay, so that's totally independent of the CNC controller, so I have to set that manually. Alright, let's see. I've got Linux CNC loaded here. And I should be able to... Oh. It's going. So this is going to home the axes. So this goes up to the limit switch and then goes down 2 inches. Now it's going to do x-axis. Same thing. And I could speed up the homing speed. So then it comes out. There's the y-axis. Man, that's slow. Can I speed it up? I don't think I can speed it up. Well, actually, wait, let's see. Jog speed. There we go. So now it just homed all the axes, and my home settings, the way I have the machine set is X is at 2 inches, Y is at 1/2 of an inch, and Z is at -2. So it goes to the limit switch, which is also the home switch, and then goes down to the home position, which is not necessarily all the way at the home switch, which would be an error because you can't have your home position be at a point where your home/limit switches are tripped. So I might do another video separately on setting up the configuration, because it's not super simple for setting up the configuration for Linux CNC, but I don't want to put too much into this video. So yeah, so I think this pretty much covers it. This is where we're at right now. It's working. I haven't done any kind of test. I put a piece of paper there. I was going to tape a marker or something to draw a picture just to kind of test the functionality, but yeah, I think I'll save that for a future video. But yeah, so I want to use this for making PCBs. So I want to make surface mount PCBs with this machine for some rapid prototyping and that sort of thing. So that's going to be a whole project in and of itself, because that's I got to learn all the software involved and how to do that, and so I got to figure all that out before I can show you this machine cutting something and doing something cool. But yeah, so there it is. We got a functional CNC machine again. So yeah, oh yeah, one last thing. This is the E-switch. So very long cord. I can take this around, and if the machine crashes, I can slap that E-switch. But yeah, I'm pretty excited. Hope this was interesting. I just kind of wanted to show it off because I'll probably be using this machine in future videos, and I might get a lot of questions about, how'd you build that? What is that? Tell me about that thing. So that's what this video was for. Alright, thanks for watching, guys. If you stuck with me through the whole video, appreciate it. Hit that thumbs up button if you enjoyed. If you're not a subscriber, hit the subscribe button, and if you click the bell, you get notified, of course, when I have new videos. As always, thanks for watching, guys, and we'll see you next time.